So this is object detection drone. So what it is, we're controlling a drone through our boards that we designed here. We're going to survey a field, detect whatever object you want it to detect, but really the idea is we want to be able to identify weeds with it, so that way a farmer can use it for weed management without having to take a plane out and crop dust the entire field. So the idea is if we can identify where the weeds are using AI, then we can reduce the overspray that would be involved with just applying herbicide to the entire field. So yeah, our device, it flies over this field, it'll identify, it'll take pictures, use that AI to identify what's there, and then we can attribute a GPS coordinate to each detection. So that way we can go back out and do the spray later. So we use the golf balls because of the season that we're working on this project in. We're working on it over the winter, so we're not gonna have weeds that we can detect. However, the nice thing is with AI object detection models, whatever sample set you give it is what it can detect. So if we wanted to refit our model for weeds, all that we would need to do is get a bunch of picture of weeds, retrain it. So it would be the same AI model, just with a different training set. Yep. And it'd work the same way with our system.
So it's like a life alert. When somebody falls down in a small room, it detects the person falling down, and then it can contact anybody for them. They can set up their phone number for who to contact. And instead of them actually pressing a button to say that they've fallen down, this system is actually built on radar. So it actually scans the room all the time. When somebody is in there, it always checks if the person has fallen down. And if the person did fall down, it triggers, and then asks the person, we detected that you have fallen, would you like us to call for help? And if you say yes or you say no, it's actually going to call the person, like send a text to the person based on that.
We really wanted to do it as something as a proof of concept, show that it can be done. And then when people have more time and more investment into it, more than just a capstone project for us, we're trying to get it free. Hopefully someone that is really invested in this can take it somewhere, market it, and try to save lives.
It's Project Quicker, we're Team 124, and our main purpose is to have a base station or rover to aid in construction and grading on job sites to get accurate longitude, latitude, elevation data to minimize human error when trying to find the correct spot to dig or filter on a construction site. So here we have our base station, and then we have our rover set up over here, the antenna, and then we have our app demonstration over here that connects to our rover and displays PDFs and then the measurements taken.
Yep. So it'll tell you who's taking your measurement and then the height of the rod that the rover's sitting on, and then the blueprint will come up. Everyone can see what the benchmark elevation is supposed to be. You click measure, and then it'll tell you longitude, latitude, and elevation, and then who took the measurement.
The data is transmitted between the GNSS model and the satellite, and I sort of have to find a way to intercept that message and then find what the data that I'm looking for. Look at specific messages, also have to make sure that the data is specific enough, because since it's measuring longitude, usually it's not accurate all the way to an inch, so I have to set it into a mode where it can measure to the inch.
We created the Sustainable Small House Indoor Air Quality Monitoring System. It's for Dr. Chen's Sustainable Small House project that they're building here just south of campus. Indoor air quality is important for the occupants' health, so we needed a system to monitor such thing as particulate matter levels, carbon monoxide levels, sulfur dioxide and ozone levels, and all those things are used to create an air quality index, similar based on the one from the EPA. So like if you ever see on the news when they give a weather forecast, they have an air quality index up there. So that's the same type of thing that we're calculating, but we're doing an active monitoring system. So we created 3 modules that will be in the 3 main rooms of the house: the basement, the utility room, and the main living room. and it will constantly collect data and report it back to the home seer automation system, which someone will eventually completely automate the house and will make decisions to where when there's a certain bad air quality inside and it's worse than the one that's outside, it will be able to turn on a ventilation unit that'll swap the air.
So our project is the localized home assistant. It is essentially the closest type of product would be sort of an Amazon Alexa or Google Home. Our device has no connection to an ISP, no internet access at all. It hosts its own local area network and a web page on it. You can actually see here is the web page that it's hosting right now live. You can add things like flight schedules to it, add new smart devices that it'll be able to control the timers on it. Additionally, it has things like voice control, as well as, like we already said, the ability to control smart lights. The type we're using in our design right now are Senglet, but it should be able to use. That's sort of the basis for our design.
So this is PLANET, which stands for Plant-Based Long-Term Autonomous Nurturing Eco-Friendly Technology. A bit of a mouthful, but how it works is it uses 4 different sensors in the soil. The 2 that we use for the healthcare functions are soil moisture and pH. And based on those, it will automatically water and fertilize it. So it reads those sensors twice a day and it'll take care of the plant for you. And we also have different settings within our home screen down here, and we can select between 4 different plant types in the home screen right here. And depending on what plant type you select, it will take care of the plant differently because a lot of plants are different. So you have to be able to water it less frequently or more frequently depending on the plant. Then we also have a light attachment.
Plants need the visible spectrum light more than they need UV light. And so that's why we chose these light colors. As I believe we explained, the colors shift throughout the day.
Another big thing that we wanted to focus on was sustainability. So we used a lot of recycled materials, and we have a very low energy consumption. At the end of the day, we're using like 5 watt-hours per hour. So it's very low compared to like a light bulb, and most of our packaging is recycled. So we're making less of an impact on the environment while trying to grow plants. That was our mission.